Superloads are oversized in shape, enough heavy that they can make the ground sink. So how transporters transport them using these much smaller and lighter trailer systems. Let us show you some of the most epic transport ever done anywhere on Earth. Make sure to like, share, and subscribe. Have you ever thought of relocating your house from a noisy neighborhood to a peaceful place? Good news, it is possible now. Watch the transport of this large house yourself. It was just 650 tons in weight. First of all, they detached the house from its foundations. Then they placed 700 bar jacks underneath it. Following that, the house was jacked up by only 2.5 meters, or 8 feet and 2 inches high. A total of 29 climbing jacks were installed to lift this house. The piston of a climbing jack extends, elevating the object in a single stroke. 2 timbers are slid below the jack, and the jack is lowered on them. The piston is then retracted, and 3 more timbers are slid beneath it. This process continues until the object reaches the appropriate height. NGUYET created a steel structure to support the house and spread the load evenly during transportation. After mounting the steel structure, the climbing jacks were removed to make space for SPMTs. If you don't know about SPMTs and how they function, don't worry. We will talk about them later in this video. Now the house is on wheels. It's time to move this sweet home to a new place. A new building will be constructed on the site where this one abandoned it. When it comes to moving large objects, NGUYET is the top choice. The company takes on the most challenging transport missions. Recently, it successfully completed the replacement of 2 bridges in Belgium within 2 weeks. However, the specific measurements and weights of each bridge have not been disclosed, but they are expected to be over 120 feet in length and weigh several hundred tons. With the MegaJack 300 system, the bridges were initially raised to a height of 8 meters. They utilized SPMTs to transport and precisely place the load onto a floating barge. The barge methodically transported the bridges, placing them carefully on their foundations. This was done to enhance the infrastructure for inland shipping around the port of Antwerp. Next, we'll see a 2 million pound roof being delivered to the Georgia power plant near Waynesboro, Georgia. This, however, is no ordinary 2 million pound roof. It is a nuclear reactor shield meant to add an extra layer of protection around the containment vessel, protecting the structure from any potential hits. 4 SPMTs were employed to transport this structure, which was 135 feet in circumference and 37 feet tall. A heavy-duty crane was then used to transport and elevate it to the top of the shield building. Here is a 560-ton load hanging from the ship crane and ready to be taken to 65 kilometers away. Most of the time, such heavy loads are transported on SPMTs. SPMT stands for Self-Propelled Modular Trailer. Unlike truck trailers, SPMTs have their own propulsion system. Each modulator is used after calculating the weight and size of the load. This massive object is an autoclave. An autoclave is a particular type of chamber used for high pressure and high temperature science and industrial processes. Sao Van and NGUYET is a gas project that began in 2017 to meet local demand and boost Vietnam's economy. The loading of the 12,733-ton jacket was the initial phase of the operation. Mammoet's engineers chose the strand jack method due to the structure's vast dimensions of 131 meter long, 81.7 meter wide, and 56 meter high. The jacket was built with a launching truss on skid beams, and breakout jacks were utilized to start transport from the assembly point. The major pulling operation was then initiated using strand jacks and winches. External high-capacity submersible ballast pumps added on the loadout barge aided coordination with the barge's internal pumping system. The internal ballast system was then utilized for deballasting. Next, we have a rotor blade adapter from Scheuerl. This is the wind energy industry's transportation solution. With a load moment of up to 900 metric tons, the adapter is suitable for rotor blades up to 100 meters or longer. It provides the optimum maneuvering options due to its 600 setup angle and rotatability. As a result, tight roadways, obstacles, and serpentines can be traversed safely. The adapter can be used with both pulled vehicle combinations and self-propelled modules. Its quick change technology ensures greater efficiency in transportation operations. The Danube Bridge in Linz is Austria's largest steel bridge, weighing more than 8,400 tons. Mammoet was assigned the duty of transferring its two supporting components, as were many other projects on this list. Each part was 100 meters long and 32 meters broad, and had to be transported from the pre-assembly area to the piers in the middle of the river. Mammoet engineers used the MegaJack 800 to quickly and safely jack bridge segments up to float in height. Both bridge sections were transferred from the assembly point to a floating barge using SPMTs. Then they were properly positioned to complete the structure. Maintaining the center of gravity between two massive buildings on a floating barge was a mind-boggling feat that Mammoet executed flawlessly. Wilson Quarry, a mining facility in Aromas, California, has been in operation since 1900. Granite Rock, the company's owner, dreamed of relocating the mining equipment deeper underground for another 100 years of operation. Sadly, they were unable to do this on their own. That is why they hired Mammoet to help finish the task. It used SPMTs to move a 690 metric ton granite rock crusher and a primary conveyor. The 8 to 10% slope gradients, however, made this a difficult, multi-day task. Once in place, a 450-ton gantry assisted in positioning the old conveyor parts over the new conveyor before they were linked to form a larger unit. The rock crusher arrived in one piece, taking less than 2 hours. Constructing a huge bridge above a busy freeway might result in months of traffic jams throughout the city. It would have happened in Edmonton, Alberta, if the 13-kilometer light rail system had been constructed using traditional methods. That is why TransEd Civil Joint Venture, the construction company in charge of this project, hired Mamaway to cast and install the concrete guideway spans near the installation site. It just took 2 nights to transport them from 100 meters distant and put them atop the SPMTs with the JS500 jacking equipment. Working at night caused only slight disturbance to regular motorists, as the roadway was reopened at 6 a.m. after each night shift. In 2018, one of Queensland, Australia's top mining corporations sought to transport its 3,000-ton dragline from one coal mine to another in its entirety. The overall distance was 100 kilometers. During detailed route assessments, Mamaway engineers encountered numerous difficulties, including 7 rivers and streams, 15 power lines, 3 railway lines, and 2 highways. Using 12 by 600 climbing jacks, Mamaway loaded the dragline onto the 48 axle lines of the Self-Propelled Modular Transporters, or SPMTs. The biggest challenge was to cross the track on time. Otherwise, it would have resulted in a month-long delay. Local preparations failed owing to adverse weather, resulting in a 5-day delay. Hats off to the Mamaway team for assuring safety regardless of the conditions. They worked extra shifts to complete the final 20 kilometers in record time, and the dragline arrived on time. SARENS is currently constructing a spin launch chamber. Let's begin by examining the transportation of this steel ring. It has a weight exceeding 1,000 tons. Boasting a massive diameter of 33 meters, the void chamber holds the title for being the largest in the world. It is commonly utilized in the aerospace industry. Can you figure out what it is? It serves as a crucial part of a large-scale accelerator designed to propel payloads from New Mexico into low Earth orbit by rapidly spinning them at astonishing velocities. SARENS was hired by SpinLaunch to handle the transportation of this massive object. Using its multi-lifting tower, SARENS effortlessly raised the load over 16 men and smoothly rotated it to 90 degrees for placement on transport trailers. An engineering challenge involves constructing a steel frame that is placed on 2 64-axle SPMTs, resembling a bridge, in order to transport it a short distance of just 200 meters. The wind, snow, and freezing temperatures presented an additional challenge. Here is a 600-ton load hanging from the ship crane and ready to be taken to 65 kilometers away.